Section 15, question 1. Find the equation of the line which passes through the point minus 1, 3 and is perpendicular to the line with equation 4x plus y minus 1 is equal to 0. Well, first of all, to find the equation of a straight line, we need point and gradient. We've got the point, we need gradient. So we know that the line is perpendicular to this line. So let's find the gradient of this line, which means we need to write in the form y equals mx plus c. So it's y equals minus 4x plus 1. You can see there that the gradient is minus 4. So next move is communicate to the examiner m1, m2 equals minus 1. So remember, for perpendicular lines for the gradient, flip and invert. So minus 4 over 1 becomes positive 1/4. So we've got a gradient which is 1/4, we've got a point which is minus 1, 3, and it goes into y minus b equals m bracket x minus a. So it's y minus 3 equals 1/4 bracket x minus minus 1, which is x plus 1. I'm now going to get rid of the fraction by multiplying through by 4. That will be 4y minus 12 is equal to 1 bracket x plus 1, which is x plus 1. Bring that over, and that will be 4y equals x plus 13. That's the final answer. Section 14, question 2. The point A has coordinates 7, 4. The straight lines with equation x plus 3y plus 1 equals 0 and 2x plus 5 equals 0, 5y equals 0 intersect to B. Find the gradient of AB. To find the gradient of AB, we need the point A and the point B. We've got the point A. We don't have the point B yet, but we can get it since it's the point intersection between these two straight lines, and that's simultaneous equations. So x plus 3y plus 1 is equal to 0. I'm going to call equation 1. And 2x plus 5y is equal to 0 is equation 2. So I'm going to decide to get rid of x's here and multiply equation 1 by 2, so that will give me 2x plus 6y plus 2 is equal to 0. I'm going to now call that equation 3. So I'm now going to do equation 3, take away equation 2. So 2x take away 2x goes, 6y take away 5y is y, and 2 take away, well, there's nothing here, so that's just y plus 2 is equal to 0 take away 0 is 0, which means y is equal to minus 2. I'm now going to sub y equals minus 2 into one of the equations, and I'm going to choose y equals equation 1 rather. So equation 1 is x plus 3y plus 1 is equal to 0. So that will be x plus 3 lots of minus 2 plus 1 is equal to 0. So that's x minus 5 equals 0, which means that x is equal to 5. I've now got my point intersection for B, which is 5 minus 2. I'm now asked to find the gradient of this line. So it's y2 minus y1 over x2 minus 1, so minus 2 minus 4 over 5 minus 7. That's minus 6 over minus 2, and the gradient of AB then is 3. Part B says, hence show that AB is perpendicular to only one of these two lines. Well, we found that the gradient of AB then is 3. So let's investigate the gradient of these two lines. I'm going to first of all check this one. X plus 3y plus 1 is equal to 0. How do you find the gradient? You find it by writing in the form y equals mx plus c. So 3y would be equal to minus x minus 1, and y would be equal to minus 1 over 3x minus 1/3. That's the first one. Second one, I've got 2x plus 5y is equal to 0. 5y equals minus 2x, and y is equal to minus 2 over 5x. So I can see clearly the gradient of this line is minus 1/3, the gradient of this line is minus 2/5. So this is looking like the one that's definitely perpendicular, because as you can see there's a close relationship between minus 1/3. So, in terms of picking up my show that mark, just be as comprehensive as possible, and something like this would do the job. So something like 3 times minus 1/3 equals -1, therefore lines are perpendicular. 3 times minus 2/5 does not equal -1, therefore lines are not perpendicular. That's the final answer. Section 15, question 3. The diagram shows a line L. The angle between L and the positive direction of the x-axis is 135 degrees as shown. What's the gradient of L? So remember, this is m equals tan theta, and theta is the angle made with the positive direction of the x-axis, so it's tan 135. So this is good knowledge of our exact values and the cast diagram. So 135 degrees will lie in the sine quadrant, so tan is negative there. The acute angle in here is 45 degrees. Tan 45 is 1, put a minus in front of it, and that's -1, and that's option C. Section 15, question 4. Find the equation of the line ST, where T is the point -2, 0, and the angle of ST was 60 degrees. So, to find the equation of a straight line, I need point and gradient. I'm going to first of all get gradient from m equals tan theta, angle being 60 degrees. So, tan theta, exact values, that's √3. So now y minus b equals m bracket x minus a, and a is -2 and b is 0. So that's y minus 0 equals √3 bracket x minus -2, which is x plus 2. So that's y equals √3x plus 2√3, and that is the final answer.